Padmalana. She is now in the second year following a bachelor degree in computer science. Her area of research interest is computer architecture and computer mathematics. Thank you. Oh, it's finished, no? Yes. Next, according to the agenda, is the presentation on colored VetriNet based model for hybrid security architecture based on reputation for secure execution of mobile agents. But unfortunately, the presenter Hemant Pathak is not available here. So therefore, we will move on to the questions and answer session. But prior to that, I must say that several presenters gave my name incorrectly as AKYW Pereira, but I am KKYW Pereira is my correct name. And also in the booklet, I have been put as Chancellor University of Morituva and also Faculty of Engineering and Computing, University of Technology, Jamaica, which is not correct. I have not even been to Jamaica in my life. So you have to ignore that. Now we will move on. Yes. We will move on to the discussion stage, and therefore I invite all the presenters to kindly come and occupy the seats for them, which is over there. All the panel members to come to the seats there. Yeah. Mr. Madhuranga, Mr. Disanayaka, Ms. Abru, and Chandima and Kanishka Malapana. Anyway, we have been listening to a very interesting series of presentations which are of practical value once they are developed to the full level. At the moment they are types of robots and so on, plus of course things like solar cells using nanotechnology, which are not yet matured and on the table, but they will definitely be very, very useful in time to come. This type of thing takes a lot of time to develop to a useful stage. But I'm sure with the enthusiasm that the presenters had, these things will become a reality someday. So I invite anybody from the audience to raise questions from the panel. And please identify your name when you ask a question, and if possible you can direct it to a particular member of the panel. Thank you.
I find Madhuranga's work very interesting, useful for context. Now I would just want to know whether, on what basis did you use copper and copper components? On what basis? Why didn't you use some other element? I mean, did you use periodic table characteristics or things like that? And also, have you made a prototype and tested this practically?
Thank you.
We we created PN junction, then P-type semiconductors. Copper iodide is a P-type semiconductor and copper oxide is a N-type semiconductor. Then we create PN junction. When we go to nano level, we can increase its particle surface area, and then we can when we use this nanoparticle semiconductors, then it absorb many energy and generate more photoelectrons, and then it enhance the photocurrent using nanotechnology. Yes, we made 1 by 3 square centimeter electrodes. Actually,
I think you should wait on this as quickly as possible. Do you think it will cause waste and
yes, sir, we made from low-cost materials. Copper is highly available and low-cost material, and copper iodide also like that material, and we can make low-cost silicon solar cells. Now industry available silicon solar cells and multi-junction solar cells using silicon base. Then silicon purification method is more high expensive. That's why that solar cells are more expensive. When we used our method, we can produce low-cost solar cells using these materials.
Can I also ask a question? How far have you gone in this venture? You have made cells already, is it?
Yes, we already made that solar cells.
Yes.
We are searching its lifetime, and we can implement near future.
Yeah, you have made prototypes, is it?
Yes.
How many have you made? 2 or 3?
Sorry, sir.
How many pieces have you made of these?
We made many electrodes,
Yes.
and we experimented as we used various methods to characterize these cells, and
Yes.
we see its lifetime. Now we actually
You have made the electrodes.
Yes.
And you have combined it into cells, is it?
Yeah.
And how many cells have you made? 2 or 3 or 5 or 1,000?
I know there are 4 layers.
Okay.
First NCU2O, then PCUI, then create PN junction,
Yes.
and then introduce dyes on top of this PN junction, and then apply CNT to increase photocurrent.
Yeah.
There are 4 layers.
Only. Thank you. Any further questions? Yes.
Yes. My question is to Rajapal sir. First of all, I will introduce myself. I'm Sant from the Electrical Engineering Department. I'm very much interested in your method, ISAM method, self-assembly method.
Let me
you showed me. Oh. My question is this: will you be able to get a uniform layer of uniform monolayer using that method?
Yes, sir.
Yes. And Again, I wanted to know what is that method other than the appropriate method.
Yeah. Then first we are making the molecular layer on a particular water surface first. As an example, it's like a water tank, fish tank. Okay. Top of the water we spread dye molecules. It's a specially synthesized one. The head and tail. Head is the chemistry part. The tail is the carbon tube. Then because of that, it flows on the water surface. Then first we float on the water surface. Then there's a floater at the end of the surface. Then we press slowly. And yes, yes, that's right. That's right. Then before depositing the samples, we adjust the sample inside the water. Slowly comes up. Due to the surface tension and everything, it attaches to the particular surface. We call that the method is Lamb-Bludgeck method. Yeah. So, then we can plant molecular layer. Plant. It's like paddy field. Then if you want to plant another layer, again we put into the water with the one layer. Again we pick up. Then second layer. So on, we can accommodate many number of artificial molecular element. Yes, this is the way that we deposit the dye. Yes. In this solar cells, there are two semiconductors, N and P. The cost is very low because we can buy 50 rupees on a particular piece of copper sheet from outside. Only 50 rupees for the copper sheet. Then we well clean it. Then first we deposit the one nano layer copper iodine, CuI. We can make it, we can synthesize. The first layer is copper iodine. Then after that, now top of that is the copper layer. The CuI layer. CuI layer is a white band. That means it doesn't absorb visible light. Yes, visible light. Then after that, top of the P, we boil this one into, we insert a copper sulfate solution. It's very easy. Even KU students can do it in your laboratory. Then we insert this copper layer sheet. Then top of the, we already fabricated PCUI. Then we insert the copper sulfate and boil it. Even we boil only just piece of copper sheet inside the copper sulfate, we can fabricate the entire one. Then okay. Then going that way, the first we fabricate P, the top of the N. N is in semiconductor is visible light sensitive. It absorbs our daily light. Now we have two P and NP junction. One semiconductor doesn't absorb, the other one absorbs. Then if we put into the solar radiation, only the upper Cu2O part absorb the light. Now we want to utilize the other part also. Then because of that, we deposit the dye. Dye penetrate into the CuI, P, into the P. Okay, P, because the layer thicknesses are very small, only the everything is nanoscale. Then dye penetrate to the CuI, the P1. Then dye, and now we put in the solar radiation, dye absorb the light, the upper layer absorb the Cu2 absorb the radiation. Dye operates the P type to be sensitive to the